Hello and welcome to What's New with VMware Cloud Foundation 2.3. Thanks for joining today's webinar. This is a big new announcement from VMware, and we're excited for you to join us on this special webinar event. My name is David Davis, and I'll be the moderator for today's event. Before we jump into it, just a few little housekeeping things I want to mention. First off is we want this to be a very educational event, so I encourage you to use the questions box there in your GoToWebinar control panel and ask as many questions as you'd like. We have expert from VMware, Kyle Gleed, available to answer all your questions. So ask away, anything to do with VMware Cloud Foundation and the vSphere suite. Also, we have a great prize to give away at the end of the event. We'll be giving away a awesome brand new Lego Death Star, something I wish I could win myself, but we'll be giving it away at the end of the event to one lucky attendee. So I appreciate you sticking with us throughout the end of the event to be eligible for that drawing. And so with that, let's go ahead and get started. First, let me tell you who I am. My name is David Davis with Actual Tech Media. I'm a 9-time vExpert. You can follow me on Twitter where I am David M. Davis. And today's event is produced by Actual Tech Media. And then I want to introduce you to our expert speaker on the event today. His name is Mr. Kyle Gleed. He's with Technical Marketing at VMware. You can follow him on Twitter at Kyle_Gleed. Kyle will tell you a little bit more about himself in just a moment. So what are we going to cover today? Well, here's the agenda. We're going to make the big product announcement around VMware Cloud Foundation 2.3, talk about what Cloud Foundation is, why it's important, how it helps you, and what's new in 2.3. And especially we'll focus in on how Cloud Foundation is the fastest path to hybrid cloud, something that most enterprises out there are reaching to get to. We'll be doing the prize giveaway, and then we'll have a Q&A session at the end of the event where we'll answer all of your VMware Cloud Foundation questions. So that's it. And with that, I'd like to hand it over to Mr. Kyle Gleed. Kyle, take it away.
All right, thanks, David. So, welcome. So again, I'm from VMware. I've been at VMware for about 7 years. I spent the first 4 years working on as part of the vSphere team doing vCenter Server, ESXi, and I moved over to the software-defined data center team, where I've been focused on VMware validated designs and Cloud Foundation for the last 3 years. And I'm very happy to be here to talk to you guys and introduce you to VMware Cloud Foundation 2.3. So this is the we've had Cloud Foundation out for about 2 years. We announced it in VMworld 20. What's the dates here? So 2 years ago at VMworld, so not last year, but the year before, we announced it. And when we first released it, we released it as Cloud Foundation 2.0. So since then, we've had the 2.1 update, we've had the 2.2 update, and now this is the 2.3. So an ongoing evolution, lots of great progress here. In terms of today, I'm going to spend most of my time I'm going to start with a quick introduction to Cloud Foundation. So it's new enough, and we find that a lot of customers are still a little confused about what we're doing with Cloud Foundation. What's the motivation behind it? What are we trying to accomplish? So I'm going to start with an overview. We'll get into the architecture, and we're going to be focusing on implementing Cloud Foundation as part of a private cloud. So we do have Cloud Foundation is a solution that can run both as a service, hosted from public cloud providers, as well as something you can deploy in your data center as part of a private cloud. We'll focus primarily on the private cloud today, but if you have questions about that public cloud side, feel free to ask those as well. We'll get into some key concepts around the idea of workload domains. We'll talk about how with Cloud Foundation, we can really make it easy to manage software updates. And then we'll end by going over some of the new features and capabilities available in this latest version and the ongoing evolution as we continue to add more and more capabilities. So with that, we'll get started. So this slide here is a slide I present a lot, and I see this slide a lot, and I feel like if I had to come up with a kind of an easy way to summarize this, the whole key to this slide is the simplest path to the hybrid cloud. And if you think about as you're looking at public cloud and you're looking to get started with public cloud and you're on that journey, it's very easy for me to log into a public cloud provider and say I want capacity, tell it how much capacity I want, and then shortly after, an hour or two later, I'm logged into vCenter Server, and that capacity is just there and available for me. So if you're familiar with our VMware Cloud on AWS service, that's exactly the experience you get. Is you can go out, you can get the capacity you want when you want it, and then if you no longer need that capacity, it's very easy to then just delete that capacity, and you're no longer billed for that. And that public cloud experience provides a lot of agility, a lot of it's very easy to use and it's very easy to consume, and that works great, and that's kind of the standard. But when we come to our on-premises infrastructure and the data centers and the racks in our data center and the servers we own, we've been successful with implementing, with providing that same type of ease of use and that same type of simplicity, in the sense that if I have a customer come to me today and say, hey, I need a vSphere cluster where I can run some workloads, and they come to me and say, how soon can you get that? We don't typically measure the time that we can provide that in hours. It's typically days, if not weeks. And so that gap is presented a challenge. So what we're really doing with Cloud Foundation, we're trying to close that gap, and we're trying to give you that same cloud kind of capability, but on your local data center. So hence the term private cloud. And with Cloud Foundation, what we're really trying to do is provide the same software stack across both private and public cloud, as well as the automation and the ease of use and the ease of consumption that would come as part of a cloud. So you can go to your private data center and you can deploy a vSphere cluster just as easily as you can go to the public cloud and deploy a vSphere cluster. And now that you have this common platform across both the private and public cloud, we're enabling that true hybrid cloud, because now if you need to move a workload from one place to the other, be it private to public or public to private, you can do that without having to worry about converting VM formats. You can do that knowing that any storage policies associated with your vSAN, such as dedupe or compression, or any NSX security policies associated with that workload, would follow that, because you have the same capabilities in your private cloud that you have in your public cloud. Today, if I'm running all-flash vSAN on in my local data center, and I want to move a workload into the public cloud where that dedupe and compression is not available, or comes at a very high cost that makes it prohibitive, it can prevent a lot of that portability that we think of when we think of hybrid cloud. But we don't always think about that as we're headed out in our journey. And so with Cloud Foundation, we're providing a standardized architecture to include a standardized bill of materials, software bill of materials. We can run on-prem and off-prem with a easy to use, easy way to consume that, and thus we enable that hybrid cloud. So that's kind of the vision here. A lot of benefits to come with this. We do implement Cloud Foundation on a very standardized architecture. We refer to this as a VMware validated design, and what we mean by that is when you deploy Cloud Foundation, you're deploying it on a prescriptive architecture that we have done extensive testing and validation. So when you're deploying it, you know that you're not guessing at design decisions. You're not hoping things will work, because you know that they will work, because VMware has implemented it, they've tested it, they've validated it on an architecture that looks very much like yours. Very standardized, very repeatable, makes it very easy to support and sustain. In addition, we're stepping away from looking at all the components that make up the software-defined data center as individual components. So we no longer focus on vSphere or vSAN or NSX, or installing a PSC and then installing a vCenter server, as much as we're now integrating this into a holistic solution that we're deploying Cloud Foundation, we're managing Cloud Foundation, we're patching Cloud Foundation. So we're moving away from the components and talking about an integrated stack. It's an engineered integration. This isn't just a bundling exercise where we've taken a bunch of different products and put them together and made them easy to purchase. We've actually done integration and extensive testing of that integration to make sure that the version of vSphere that we're running is compatible with the version of NSX, which is compatible with the vRealize Suite components, in a way that it makes it very easy to consume. And as updates become available, those updates can be rolled in as well. And of course, the key to all this is the simplicity around the ability to operate. So again, providing that kind of cloud experience on-prem as part of the infrastructure you own, making it very easy to deploy the software, making it very easy to create clusters and to expand clusters and to delete clusters, making it very easy to roll in software updates. And we do that through the lifecycle automation capabilities of the VMware SDC Manager. And so, as I mentioned, this is an integrated solution, and as such, we do have a software bill of materials. And this slide here is just really meant to kind of give you a summary of all the different software components that are part of Cloud Foundation today with the 2.3 release. You'll notice that we have fully automated deployment of each of these components. the list of versions. So we just announced Cloud Foundation 2.3 on Tuesday of this week, so 2 days ago. And with that announcement, we're still wrapping up the final development effort, and we will release the product. They'll have its general availability towards the end of the month. So there is a possibility that maybe some of these version numbers, the specific pack levels might change. But the point here being, as you see, we have a very specific set of the components and the versions that are tested and integrated as a holistic integrated stack that we know will work together, that's compatible, and that all the interoperability will work. And then as we go forward and as new updates become available, we will then update this software bill of materials. So that's the list of components. And then those components are going to run on a very prescriptive hardware architecture as well. The building block to Cloud Foundation is the physical rack. So within the data center, I have my physical racks. Inside each rack, I'm going to have a pair of top of rack switches, a management switch, and a number of ready nodes. So this is a hyper-converged infrastructure solution. We do leverage vSAN, and as such, the nodes are vSAN ready nodes. You'll be able to deploy a minimum configuration is 1 rack with as few as 4 ready nodes. We can scale this up to 8 racks with as many as 256 ready nodes. When you go into that multi-rack configuration, we do reintroduce this requirement for some inter-rack switches to tie these together. And the result here is a very highly scalable architecture that allows you to start small, grow very big, and in a way that's very easy and very modular. The hardware that we use does need to be qualified for use with Cloud Foundation, and we do maintain a list of all the qualified hardware on our VMware compatibility guide. So here you see a screenshot showing an example of that website where you can go in and search based on the different ready node vendors, the different configurations, whether you want all flash or a hybrid, as well as your different switch vendors. You can basically find out the list of the qualified hardware that you can use to run Cloud Foundation. And so we take this software bill of materials, we take this hardware architecture, and we basically put together a architecture on which we run Cloud Foundation. Now, again, this is a modern hyper-converged infrastructure architecture. So the point here with that is when you look at Cloud Foundation, a lot of times I'll get asked by customers, do I have to buy vSAN? Do I have to buy NSX? Can I exclude those components? Can I try and reduce the cost? And the answer is no. This is a holistic solution. It's an ACI architecture of which vSAN and NSX are integral components, and they are part of the design. So it is a modern ACI architecture. Again, it's a VMware validated design, meaning that we do extensive testing and validation of this design. So we are running this at VMware, and we're doing all our testing and validation on an architecture that looks just like what you're going to have at your data center as well. So that helps instill confidence, helps ensure stability and reliability. The design is repeatable, very scalable, and that comes with a lot of benefits. And then again, the deployment is fully automated using the VMware SDC Manager. And I'm going to go through some slides and show you exactly how that automation works. And again, while I'm focused on the private cloud in this presentation, it's important to keep in mind that VMware Cloud Foundation, this architecture is available not just to be deployed inside your local data center as part of a private cloud, but we can also be consumed as a service from public cloud providers. IBM, CenturyLink, Rackspace are examples. In addition, you're probably all likely familiar with the VMware Cloud on AWS, which is powered by the same underlying Cloud Foundation infrastructure. So in terms of deployment types, I just have this slide here. I don't want to spend too much time on this, but I mentioned we can start very small and we can grow very large. And when you start out with those small configurations, we call that a consolidated architecture. And we want to kind of draw a distinction between the consolidated architecture and the standard architecture to kind of help just understand the way you would scale the solution out. So the idea here is we make it very easy for customers to get started with Cloud Foundation with the consolidated architecture and then grow the environment. And as they grow the environment, they'll move to the standard architecture. And so if we look at the consolidated architecture, essentially what we're talking about is a deployment with 6 or fewer servers in a rack. And those and what we do is because the minimum number of servers required for a cluster is going to be for the Cloud Foundation, for the first cluster is going to be 4. And as you add additional servers up to 6, you don't have enough servers to create multiple clusters. But however, you have a lot of capacity. And some of that capacity is going to be used to host infrastructure workloads, what we call management workloads. And then the rest of that capacity is available for hosting user workloads or compute workloads. So what we do is we leverage resource pools on that cluster, so vSphere resource pools, and allow you to then co-host or co-reside the infrastructure workloads together with the compute workloads on that vSphere cluster. And that works very well for those smaller environments. However, as you grow your environment out, and as you're going to get into a situation where you're going to have multiple clusters or multiple workload domains, you're going to want to move to this standard architecture where you're going to start creating separate vSphere clusters and use these separate vSphere clusters to back these different types of workloads, in which case you'll want to then segregate your infrastructure workloads off onto the management workload domain, and then have your compute workloads running on top of these separate VI of virtual infrastructure workload domains or VDI of virtual desktop infrastructure workload domains. So that's the standard architecture. So the point here is not to confuse you with different architecture discussion this early in the conversation, but just basically point out that with Cloud Foundation, with the design, we've got a very modular, very scalable design that allows you to start small and grow very easily and very simply. We're going to talk a lot more about workload domains, and so I'll just kind of cover that later. Now, I want to take a minute here and just talk about the automation around Cloud Foundation and how we go about automating deployment and implementing and instantiating what we would call a private cloud. So in terms of implementing a private cloud, it's really going to be 3 steps. Now, you as a customer may perform all 3 of these steps, or you may work with an integration partner who may perform some of the steps, and you as the customer may perform other steps. Again, getting back to the flexibility, we have several options for how you can get started with Cloud Foundation. The first step is, you're going to have physical hardware. So you're going to have a physical rack. And let's just say you're going to have a physical rack in your data center. You're going to bring in 12 Red-Day nodes. You're going to have a 2 top-rack switches and a management switch. You just spent the first part of the week racking those servers up and cabling everything up so everything's plugged into the right ports. You're now ready to get started with Cloud Foundation. So, but at this point, there's no configuration on those switches. There's no operating system. There's no configuration. There's nothing installed on the host. The hosts are just spinning tin, waiting for you to install the hypervisor. So you have this physical rack that's there. It's got power to it, but it's got nothing installed on it. So we're going to need to prepare that rack for Cloud Foundation, and we do that through a step we call imaging. And so the first step is going to deploy the imaging appliance, which we call the VIA. And then we're going to image the hardware or prepare it for use with Cloud Foundation. And then we're going to instantiate the private cloud or deploy Cloud Foundation in a process we call bring up. And so the way this works is we're going to use this VIA appliance again, and this is a self-extracting OVA file that's going to extract with the default settings. There's no configuration needed here, but you're going to need to have a jump host. You're going to extract this OVA file, and then you're going to connect this OVA, this VIA interface, and you're going to use it to image the rack. And so this is something that you may do as a customer, or if you're working with an integrated partner who's providing an integrated Cloud Foundation service, a rack that's pre-configured for use with Cloud Foundation, they may do this for you. But anyways, that's the VIA, and it's important to understand the VIA because when we come back to our first step here of deploying the VIA, we're going to need a jump host on which we're going to deploy this. That jump host can be a Windows box, it can be a Mac box, it can be an ESXi host where you're going to deploy. Just need a place you can deploy that OVA. And so what you're going to do is you're going to have that physical rack again that has no identity but is ready, just waiting for you to deploy Cloud Foundation. And you're going to start by going out to the myvmware.com and downloading Cloud Foundation. You're going to download 3 bits of information. There's going to be the VIA, which again is that OVA file. You're going to download an ISO file, which is going to be the Cloud Foundation software bundle. So this is going to be a large ISO that's going to contain all the software-defined data center components. So that software bill of materials we've seen earlier, the PSC, the vCenter, the ESXi, the NSX, that's all included inside that software bundle. You can download that, and then you can download the MD5 sum associated with that software bundle so we can ensure the ongoing integrity of that as we upload it into the VIA. You're then going to take a network cable and connect that jump host up to that management switch in that in your rack. And then once that's done, you're going to go in and just deploy the OVA. So if you're using Workstation or Fusion, or whether you're using the host client, you're just going to go in and deploy that OVA, and you're going to instantiate the VIA. And once the VIA is up and running, you're going to then mount that ISO file on that VM, where you're going to upload it and activate it inside the VIA. So once that's done, and again, that could be done by you if you're going to do the rack imaging yourself, or if you're going with somebody like Dell EMC and their VX Rack SDDC, or one of our other integration partners, you're going to be able to, they'll do that for you. And then once that's done, you're ready to image the rack. And when imaging is how we prepare this physical hardware for the private cloud. So we're basically going to go in now, and we're going to tell the VIA what's inside the rack in terms of number of components and the make and model of those components. So how many top of rack switches, how many management switches, what's the make and model of those, how many ready nodes, what's the make and model of those. And then what's going to happen is it's going to take those environmental inputs that you give it, and then it's going to instantiate a DHCP server on the VIA. And it's going to PXE boot the management switch. Whoops, going the wrong way. It's going to PXE boot the management switch, and it's going to then install the operating system and configure the management switch. It will then PXE boot the top of rack switches and configure the top of rack switches. And again, we know the make and model of these switches because you told the VIA during the input phase. And so now we know the configuration we need to put on these. And then it's going to then, once it's configured those switches, instantiate a private network that's going to give us network connectivity across the rack. So we're going to be able to talk to the top of rack switches, and we're going to be able to talk out to all the ESXi hosts, all the ready nodes. And so with that network connectivity, we can now PXE boot the ESXi host and install ESXi. So we can PXE boot those ready nodes and install ESXi. So now that's done, we have basically given that rack an identity. We've got a private network, and we now have ESXi installed on all the ready nodes. So now the last step is we're going to take the first node in the rack, and we're going to deploy the software bundle, that ISO file. We're going to copy that onto that, and then we're going to deploy the SDC Manager. So we copy the ISO bundle, we deploy the SDC Manager, which is actually made up of 2 VMs, but we're going to deploy those VMs on that first node in the rack. And that is going to complete the imaging. So we're now ready to go in and instantiate our private cloud, and we do that in a process that we call bring up. And so during bring up, this is where the SDDC Manager comes in. So we talk about the SDDC Manager. We talk about automating the full life cycle of the software-defined data center to include the initial configuration as well as the ongoing deployment and the patching. That's all managed through the SDDC Manager. And so this is the first time we're going to actually connect to the SDDC Manager. So the way we do that is now that we have that jump host connected to that management switch, and we have deployed the SDDC Manager, we're able to connect to it using a web browser. And then we're going to do some initial setup where we do some time sync, we do some validation to make sure the hardware is all responsive as we need it. We're then going to prompt the user for inputs. What are the VLANs they want to use? What are the subnets associated with those VLANs? And then also, how is this rack going to talk out to the data center network? What are the uplinks? What type of uplink is it? Is it L2, L3? What are the speed of those uplink ports? We're going to provide that input to the SDDC Manager. Then the SDDC Manager is going to go in, and it's going to essentially create what we call our management domain, or create a management cluster, where it's going to take that node 0 where we staged the SDDC Manager and copy that software bundle, combine it with 3 additional nodes in the rack, and create a 4-node vSAN cluster, on which it's then going to instantiate our SDC by deploying our platform service controller, our vCenter server, NSX, log insight. But once that's done, we're now SDDC ready. We now have a private cloud. We're now ready to connect to the SDDC Manager and start deploying workload domains, to start carving out that pool of capacity, which is represented by the remaining servers in that rack. Or if I'm adding additional racks to this server, that capacity becomes a pool that I can now allocate by going out and creating workload domains. So I just want to kind of stress here that as we do this, while this all looks very easy, and especially when animated through graphics and stuff, at the end of the day, we're taking over 120 separate tasks, and we're orchestrating those through the SDDC Manager in order to accomplish something that's quite complex. So here I'm just kind of throwing out a list of these tasks to just kind of give you an idea. And if you think about all these tasks, and you think, if I had to do this manually, how long would it take? And what are the areas where I might make mistakes in terms of typos or misconfigurations, and how much time would I spend troubleshooting and things like that? And the bottom line is when you want to deploy this manually, you're looking at several days. And in reality, we find based on our experience with PSO and real world customer examples, is we're really looking at something that takes multiple weeks to accomplish. and we're able to automate it into just a few hours, from start to finish. To do imaging and bring up, in my environment here in my lab, I can do it in about 4 hours. So within a half day, you could have up and running software-defined data center, and you can be able to start going in and consuming that and creating clusters and hosting VMs in a very short period of time, from the time that the hardware is racked and stacked, and you leverage that automation to really provide a lot of value. And so once that's done, like I say, you're now ready to start going out and allocating that available capacity out to your end users, out to your customers. And you do that by creating clusters. And we call clusters in Cloud Foundation workload domains. And so here's an example of, so again, a workload domain is a dedicated vSphere cluster. It's fully provisioned by the SDC Manager. So we're gonna provision the vCenter servers. We're gonna configure the data centers. We're gonna configure the clusters. We're gonna configure the disk groups, the vSAN data store, deploy NSX, and configure NSX. In addition, we're going to register that cluster with log insight. We're gonna register that cluster with vRealize operations and register as an endpoint with vRealize automation. That's all automated. And so we're able to do this very quickly and very effectively. Once I create a workload domain, I can then go in and expand it. I can add more hosts to it. So I can start out with 4 hosts. I can make it 5 hosts, 6 hosts, all the way up to the vSphere limits of 64 hosts. And then I can also delete it when it's no longer needed. So if I have a development team, they start up a project, they need a cluster, I create the cluster for them. 3 months later, they no longer need it. I can delete that and return that capacity back, and now reallocate that capacity for other other of my customers very easily, very quickly. There are currently 3 types of workload domains. The management workload domain, which we talked about, is configured during bring-up. There's also a virtual infrastructure workload domain, which is just an empty vSphere cluster. And then there's a virtual desktop infrastructure, or a VDI workload domain, which is a workload domain with a Horizon stack pre-installed, pre-configured, and desktops deployed for us, all through the automation. And so we can have multiple workload domains running in parallel, with up to 15 workload domains running in a Cloud Foundation instance. Now, one of the questions I'll get quite often is, why 15? That is because each of these each workload domain, it represents a separate vSphere cluster with a separate vCenter server. These vCenter servers are going to run in enhanced link mode, and the vSphere 6.5 configuration maximum for a number of vCenters that can run in enhanced link mode is 15, so we inherit that limit. One other thing I want to just kind of pause and just kind of emphasize here as we kind of get more into workload domains is, just because you can deploy 15 workload domains doesn't mean you will deploy for 15 workload domains. The number of workload domains that customer would deploy is going to vary from customer to customer based on their requirements. So when you buy Cloud Foundation, you do have to purchase vCenter, but only one vCenter license. We don't charge you an additional vCenter license for every workload domain you create. And depending on your environment, you may choose to have 1 workload domain, you may choose to have 2 or 3 workload domains. Again, that's a choice that the customer is going to make based on their requirements. There's nothing within Cloud Foundation that is imposing a requirement that you have a proliferation of vCenters in your environment. Instead, it's based on a decision of, if I have different workloads that have different availability requirements in terms of or different access requirements in terms of role-based access control, or different, you base those decisions based on your requirements and your needs. There's not any type of a self-imposed need to create multiple workload domains. So this is an example of the management workload domain, just showing the components that reside inside the management workload domain. There is 1 management workload domain per VCF instance. So whether I have 1 rack or 8 racks, there's 1 management workload domain. The management workload domain is where we host all these infrastructure components, as you can see there on the slide. One thing to keep in mind is that the management workload domain is not static. If I start with a management workload domain and it has 8 VMs in it, as I deploy additional workload domains over time, additional VMs are going to get added. So for each time I deploy a new workload domain, additional VMs are going to get added. So it's important to factor that in as you're looking at your capacity and the sizing and stuff, is you want to kind of have that end state in mind. How big do you envision getting? How many workloads do you plan on having, and to size that management workload domain accordingly. You can go in and extend the management workload domain over time, so it doesn't have to start big. You can start small and then add additional nodes as you grow, but it is not static. So as you deploy, the management workload domain will get set up first and bring up, and the number of VMs hosted in that management workload domain will grow as the environment grows. And so with that in mind, here's a slide to kind of help illustrate the role of the management domain and some of this idea of how it can grow. So for example, here's a list of the components running inside my management workload domain. You'll see I have my PSCs, my vCenter, my VROps, Log Insight, and my NSX Manager, my NSX instance. Now, if I go in and I deploy a workload domain, you'll see that that workload domain is going to be instantiated as a separate vSphere cluster with its own vSphere instance, its own vSAN data store, its own NSX instance. The vCenter server NSX Manager that is going to manage that cluster is going to run inside that management workload domain. And as I create more workload domains, I'm going to see additional vCenter servers and NSX Managers deployed inside that management workload domain as well. If I deploy VDI and I deploy the Horizon stack, the Horizon security servers, the Horizon connection brokers will also run inside the management workload domain as well. So again, just kind of emphasizing and underscoring the fact that the VMs that run inside that management workload domain will grow as the environment grows. So within this, you have a separate dedicated vCenter and NSX instance for each workload domain. They will all be registered with a pair of PSCs. So we have a common SSO domain, which gives us that enhanced link mode. And the other thing to point out here is the vRealize operations, vRealize Log Insight are centralized in the management workload domain, meaning you don't get a separate instance of VROps or Log Insight every time you deploy a new workload domain, as much as that workload domain is then going to be registered with the existing VROps and Log Insight in the management workload domain. So this slide, I'm going to just kind of go over this one real quick, but basically this is just pointing out that when it comes to the management workload domain and its role in the private cloud, it's a very critical component. As such, we need to be able to protect it, and if we have a component level failure, be able to recover. So we do have guidance, and we do have some utilities to help with backing up the management workload domain. In addition, we do have integration with the UI that allows us to go in and to schedule those backups on a reoccurring schedule. In addition to being able to schedule the backups, we can also go in and take them manually. And as well, anytime I do any type of a major operation within Cloud Foundation, within the SDC Manager, such as adding a workload domain, deleting a workload domain, extending a workload domain, or changing passwords, it will also automatically capture a backup as well. So backing up the management workload domain is important, and we do include in part of the product and in the documentation guidance on how to do that, and we do allow you to schedule that. So looking at each of the different workload domains in a little bit more detail. So a virtual infrastructure workload domain is just a vSphere cluster. Again, it has its dedicated vCenter server with its own vSAN data store and its own NSX instance. It's very easy to create. You simply go into the UI, you're going to click on Add Workload Domain, and you're going to configure VI, so virtual infrastructure. It's going to prompt you for some inputs in terms of availability settings, capacity settings, as well as network settings in terms of what type of networks are we going to use. Is this workload domain going to be private, or is it going to have public network connectivity? We'll provide those details. And then it will go in and it will invoke what we call a workflow that will go out and automate the task of creating that. Once you create the workload domain, you'll see the workload domain will exist. So here it is, WLD01. At this point, the SDC Manager is created the workload domain, so you just simply log into the vSphere Web Client and manage it just like you would any vSphere cluster. So here you see up in the top left-hand corner our WLD01 with its 3 hosts, its NSX controllers. Again, the vCenter server managing this workload domain would be running inside that management cluster that we see below it. So very easy to create. Under the covers, what we're doing is we're taking a bunch of different tasks, over 50 separate tasks that you would have to do manually, and we're orchestrating those into a nice workflow that can be deployed very quickly and very easily. And as I deploy more VI workload domains, I just repeat this process as well. And again, I can always expand these workload domains as I need them, as they grow, and I can also delete them as they're no longer needed and return that capacity back to my free pool, so to speak, so that I can then use it elsewhere. So now if we compare that to a virtual desktop infrastructure, so like I mentioned, the difference between a VI and a VDI workload domain is really that the VDI workload domain includes the Horizon 7 that gets installed and configured for us to provide those virtual desktops. The experience is largely the same. I go into the UI, I click on add workload domain. This time I choose configure VDI. The line of questioning is going to be different because I'm deploying Horizon, there's going to be some additional prerequisites here. There's going to be a need to provide some information about some Windows ISO images that will be used to deploy some of the Horizon components. There's going to be a need to have an OVA template for our desktops. There's some additional networking requirements. So we see here listed kind of the requirements. The line of questioning is slightly different because here we're selecting the deployment type. Are we just going to reserve capacity, or are we actually going to deploy desktops? Are we going to deploy instant clones, link clones, full clones? Are they going to be floating desktops? Are they going to be dedicated desktops? Are they going to be available from inside the network or outside the network? In other words, are we going to deploy security servers? So as you can see, we're asking the relevant questions to help us to be able to deploy Horizon in a way that will meet the customer's needs. Again, the way we do sizing for VDI is by basically asking how many desktops and what are the size of those desktops. So for the VI workload domain, we ask for capacity in terms of CPU, memory, and storage. Here we're saying how many desktops, and we'll figure out the size based on that. And then here we see we're providing the Windows Server image as well as the OVA for our templates, our desktop templates. And then we'll go off and again kick off workflows. And here we see there are actually two workflows that get invoked. So the one workflow is going to go out and create that vSphere cluster. That's going to be those 50 tasks that we've seen automated before as part of the VI workload domain. Then the second workflow is going to actually kick off another 60 tasks, which are then going to deploy the Horizon. And then you have your cluster. And so here we're seeing an example of the components deployed inside the management workload domain with the Active Directory servers, connection servers, composers, inside that management workload domain. So again, the workflow here. So here we just kind of look at the first workflow, those 50 tasks plus this second workflow, which will do an additional 60 tasks. You can kind of see the power of the automation. All right, so now I'm getting ready to, I'm going to talk about Lifecycle Management, then we're going to get into the new features of 2.3. In my personal view, I think Lifecycle Management is probably one of the best features of Cloud Foundation. And for no other reason than the simplicity it provides around maintaining software updates. I think this is just awesome. So with Cloud Foundation, as part of the SDC Manager, remember we had that software bill of materials, and when you first seen that slide, you'll notice it was quite a long list of software components that make up the software-defined data center. vSphere to include our PSCs, our vCenter server, our vSAN, our NSX, as well as the SDC Manager itself. So for those components, we're going to have software updates, and we're going to need to be able to manage those updates within our private cloud. And we have to be able to do this in a way that will ensure the ongoing compatibility of these different products, as well as the interoperability across products. So if I update a PSC, I got to make sure I don't break my vCenter, my NSX instance, for example. And so that's all automated for us by the SDC Manager. So and the way it works is as updates become available, we will package those updates into what we call bundles, and we make those bundles available through a public repository called depot.vmware.com, and then the customer can then go in, see notification through the SDC Manager of the availability. They can then go in and review those updates, and they can then download them and then schedule them. And then as they schedule them, they can apply the updates on a workload domain by workload domain basis. So I can deploy the updates to a test workload domain, make sure they don't break my application, and then when I'm ready, I can then repeat that update on a production workload domain, and so I can kind of roll them in that fashion. So another way to kind of look at this in a way that kind of helps illustrate some of the benefit here is, so within the software-defined data center, when it comes to the patching and upgrade, we do patching and upgrading for the vSphere, the vSAN, the network, and the SDC Manager itself. So we don't do 100% for all the components yet. So some of that's a roadmap item, but you'll see for the components we do have the automated updates for. If we just take these three of the four components that we do Lifecycle Management for today, we break those out, you'll see there's a number of different products. And so for each of those products, there's going to be a number of different updates that come available over time. There's really no coordination from the time that the NSX team might release an update from the time the vCenter team releases an update. So we kind of see this staggering of updates over time. And as a customer, one of the challenges we've always had is, okay, how do I go in and how do I coordinate applying all these updates? You know, we have KB articles that have big spreadsheets to talk about orders, and we have to maintain a tendency. We have to read release notes. There's a lot of work that goes on. And with Cloud Foundation, what we do is we take that responsibility away from the customer, and we're going to go in and we will manage these updates, and we will basically track the updates, and we will basically take the updates and compile them into updates that are Cloud Foundation updates. So for example, we take the 2.2.0.1 update for Cloud Foundation, and it might include NSX, vSAN, and vSphere updates. And then 2.2.0 to 3 will include different updates. But we do this in a way that kind of, remember, this is a unified bundle. It's an integrated bundle. So we're kind of going to mask the underlying complexity of the different software components. And we're going to understand that they have dependencies. And what we're going to do is we're going to layer on top of that the SDC Manager, which is going to take care of all that for us. So from a customer standpoint, they just go to SDC Manager. They don't have to worry about interoperability. They don't have to worry about dependencies or compatibility, because SDC Manager is going to take care of that for them. So now they can just go in and they can say, I'm going to deploy the 2.2.0.1 update to my Cloud Foundation environment. They'll know what components are being updated, but they don't have to worry about which order, because SDC Manager is going to take care of that for them. And then they don't have to worry about making sure that 2.2.0.1 gets installed before 2.2.0.3, because SDC Manager, again, is going to take care of that. In addition, once we have all that done, we can then go in and, as I mentioned, deploy these updates on a workload domain by workload domain basis. And it even goes so far as to understand that within the workload domains themselves, there can be dependencies as well. So for example, I have a single pair of PSCs running in my manager workload domain. So before I can update my vCenter, I might need to update the PSCs in the manager workload domain first, and it will understand that dependency. So as you can see, we're taking a lot of the complexity traditionally associated with patching and updating software, and we're basically providing a layer of automation through the SDC Manager LCM capabilities to help simplify and to help really make it easy to manage updates over time. So let's look at an example of what this might look like. So here you'll see the dashboard. You'll see that I have a notification up there at the very top. It says new bundles available for download. So I can go ahead and click that link to view the bundles, or I can click on the Lifecycle Manager link on the left, and it will basically get me to a page where I can see the list of available update bundles. So you'll see here I've got 3 updates that are queued. One of them has the update button, meaning I can go ahead and schedule that now. The other 2 are showing a status of update pending. So, you know, previous update required. So basically, this is again showing how we're enforcing those dependencies. We're basically saying that before you can install these other updates, you need to install this update first. So I go in, I click on the update. Well, actually, I can click on the little more link. So you see here, there's a more link to the left. I click on that link, and it will actually show me what's inside each of the updates. So again, I have full visibility. I know what's being updated. We're not hiding any of that. But once I'm ready to apply that update, I can click on that update button, and you'll see it will take me to a very simple calendar where I can schedule the time and the day that it will be executed, will be applied. And then once it's applied, well, then I go in and select which workload domain will be updated. So I can select them all, or I can select individuals. And then it will go in and apply that update. Then once that update's applied, you see that the next update on the list becomes available. And so we're able to roll these in a very easy, very seamless way with no downtime to the hosted VMs, and in a way that makes sure that we don't break or cause any problems in terms of dependencies or interoperability. All right, so that's a quick overview. And so now let's jump into the last few minutes here and talk about new features and capabilities available or to come with the latest version, Cloud Foundation 2.3. So as I mentioned, we just announced 2.3 on Tuesday of this week. So this is very recent news. This is just a summary of the features, and I'm going to go through each of these in detail, so I'm not going to spend a lot of time on this slide, but so let's go ahead. So the biggest thing with, probably the most significant thing with Cloud Foundation 2.3 is that where in the past, the SDC Manager and the automation we provided focused primarily on the infrastructure, and we had a requirement to manually layer on cloud management. Now with 2.3, we've extended those capabilities of the SDC Manager out to include the vRealize suite as well. So now we leverage the automation to deploy vRealize operations and automation. When you do bring up, we automatically deploy vRealize Log Insight, and the slide's a little misleading because we've always deployed Log Insight, even in the earlier versions. However, so really the enhancement here is the addition of the vRealize Operations and Automation. It's not required. You don't have to deploy these components. You deploy them after bring up. So when it says day 2, that's basically meaning that we deploy them after bring up. So during bring up, you'll get the log insight. Then after bring up, you can go in, and if you choose to use VROps or VRA, you would then deploy them. You'd go in and manually say, I want to kick this off, and then the workflow would be generated that will go out and trigger the configuration of the deployment configuration of those components. Now, in terms of how we are deploying these, so we do deploy them in a very robust and enterprise scale deployment based on the VMware validated designs. So if you're familiar with the VMware validated designs, you'll know that we have very, very prescriptive guidance on how to deploy VRA in a very highly available, very scalable capacity. And within Cloud Foundation, we're leveraging that VVD guidance to deploy in that same configuration. We are leveraging the vRealize Suite Lifecycle Manager. So if you're familiar, VMworld timeframe, we announced the vRealize Suite Lifecycle Manager. This is an appliance that the vRealize Suite team has made available that will automate the deployment of the vRealize components. And the SDC Manager is just going to leverage that under the covers. So we're going to go to SDC Manager. We're going to tell it the configuration we want. We're going to pass that configuration out to the vRealize Suite Lifecycle Manager, which will then do the actual deployment of the components for us. Then we'll come back to the SDC Manager, where we'll go in and do things like deploy the optional components such as edge services, gateways, and configure load balancers and do those things. Once we deploy the vRealize automation, we can then go in and we can identify any workload domains, any current or any future workload domains for which we will automatically register them as endpoints, so that we can leverage the blueprints and the templates in vRealize automation to now deploy workloads into those workload domains. We're currently deploying vRealize automation version 7.3. And again, we are doing a highly available configuration with NSX Edge Service Gateways acting as load balancers in accordance with the VMware validated design. So it's a very robust enterprise class implementation of VRA. VROps is very similar in the sense that we're again leveraging the vRealize Suite appliance. It's the same basic process. Here you have some additional options in terms of sizing that will be done. And the other couple of notes here is we're deploying vRealize Operations version 6.6, and we also include the management packs, the pertinent management packs with that. So that's the vRealize, extending of the SDC Manager capabilities out to include the vRealize Operations, vRealize Automation, and encompassing most of the components of the vRealize Suite. In addition, we are introducing a feature we call Heterogeneous Server Support. And so essentially what this is this feature, in the past with VCF 2.2 and prior, we had a limitation where we would require all the servers within a rack to be the same in terms of make, model, as well as CPU and memory and storage configurations. This created some challenges because, as we know, not all workloads are the same. Some workloads would require more beefy servers, some workloads would require smaller servers. And so really what we want to be able to do is we want to be able to align the workloads running on the workload domains with the size of the servers being used for those workload domains. And different workload domains will have different requirements. So with that, in order to help support that, we've relaxed that requirement, and we now support having different servers, different server configurations within a rack. So I will point out that this is we do require all the servers be the same vendor and the same family of servers. What we're talking about here is the ability to have different configurations. So I could have some servers running all flash, other servers running hybrid for their vSAN configuration. Some servers with more memory, some servers with less memory. I can optimize for different types of server configurations, and then I can then go in, and when I create workload domains, I can then choose from these different configurations in order to make sure that the servers back my workload domain are kind of sized in accordance with the workloads running inside that workload domain. And so the real benefit here again is it's providing that flexibility. You can align the workloads with the servers behind them. And this is going to help facilitate running the different types of workloads together within the single rack to help optimize that rack space within our data center and allow us to better utilize that available space. I can run test and dev and prod, or I can run VDI, all in the same rack on separate vSphere clusters. So that's the heterogeneous server support. As part of this, we've had to make some updates to our UI because we cannot just assume that all the servers are the same, we have to be able to provide a way for the user to go in and specify which servers they want to use when creating a workload domain or when doing bring up. So we have added in the UI the ability here, you see a screenshot here, to do that server selection. With this, we have introduced two new concepts, one being the idea of compatible and incompatible servers, as well as balanced versus unbalanced workload domains. And what that means is for servers, when you go in and you create a workload domain, you'll select your first server for that workload domain. We will then filter the results to make sure that if you selected an all-flash server, that all the other servers that you add to the workload domain are also going to be an all-flash, or if you choose a hybrid server, we'll make sure that they're all hybrid. So we'll make sure all the servers within the workload domain are the same in terms of their configuration, vSAN configuration, be it all flash or hybrid. In addition, as you're choosing the servers, because they can now have different configurations in terms of CPU and memory, we provide tips in the UI, kind of guardrails to help steer you to make sure you select servers that match. So we don't create a situation where you have an unbalanced workload domain, for example, where I have some servers with lots of memory and some server with less memory, thus creating a situation where I could have, if I lose one server, I could get into a situation where potentially I wouldn't have enough capacity on the surviving servers to fail over because my workload domain would be unbalanced. So again, the UI improvements here to allow you to specify the servers, and we have the guardrails to help ensure that you always create compatible and balanced workload domains. So another new feature here is this idea of being able to support vendor-provided ISO images. So when you download the software bundle, included in that bundle is going to be the ISO images that VMware is providing. And those ISO images will be the ISO images that were available at the time we released the bundle. Well, let's say 6 months later, your hardware vendor comes out with a new server that's on it's qualified for use with VCF and is available. However, requires an updated set of VIBs, an updated ISO image, but that ISO image is not part of the download bundle that's available from VMware. So prior to 2.3, we didn't really have a way for customers to easily update that ISO image in the VCF bundle. They would have to wait for VMware to get it, wait for VMware to push out a new update and go through that channel, which can cause delays from the time that a server might be available to a customer until that customer might be able to image it, use it with Cloud Foundation. So with this, we've now added to the VIA the ability to basically download those ISO images from the vendor and to basically import those and overwrite the version in the bundle so that we can help customers be able to better take advantage of new server architectures and the related ISO images that those vendors provide more readily without having a dependency on VMware. All right, so here's an example, kind of a blow up of those capabilities in terms of, you see here the modify ISO tab and the ability to go in and to basically specify the vendor and to add the selected ISOs. So just an example of that. All right, the last feature before we kind of wrap it up here is, so with Cloud Foundation, I mentioned earlier when I talked about the Lifecycle Management, we have this ability now to where as new updates become available, they'll get posted in a public repository we call the depot.vmware.com, where customers can then point their SDC Manager and be notified as new updates become available, and they can then download them. Works great unless you have a situation where for whatever reason, be it security or a policy or other type of physical limitations, your SDC Manager is not able to connect to that public repository. So if your SDC Manager is not able to go out and talk to that public repository, we need another way to get those updates in. And so with 2.3, we're providing this update bundle utility that will allow us to then take, you can basically run a script on the SDC Manager, which will create a marker file, which is, in a sense, kind of an inventory of what you have deployed. You can then copy that marker file along with this utility over to your laptop. And it can be a Windows box, a Linux box, a Mac box. It's a Java utility. You would then copy over to your laptop. You take your laptop out to where you have that public network connectivity. It would then, you run the utility, it would then compare the marker file with the available downloads in the depot and identify what updates are available and download those to your laptop, and then you can securely transfer those into the SDC Manager. So it's a way for us to basically download updates without having to require the SDC Manager to have access to that public repository. and we can then download those and move those over. And then once they're inside SDC Manager, they become available for us to then schedule and apply just like normal. Right, and of course, with each release, we always are extending our hardware compatibility guide, and a couple of notable improvements here is the support for the new Intel Skylake Purely servers, as well as the support for the new Arista 7280 top-of-rack switches. And so with that, that wraps up the bulk of the presentation. I see a couple different options for Q&A. I'm trying to see if there's any questions, but if there are questions.
Great presentation, Kyle.
Yeah, so yeah, I'll open up the questions, and David, hand it back to you.
Okay, excellent. Yeah, really great presentation. Lots of new features available in VMware Cloud Foundation 2.3, and I appreciate the overview on what it is and how it works. So at this point, there might be some folks out there who are interested in whether or not they won this Lego Death Star. So the prize winner selected at random was Tom Johnson of Pennsylvania. Congratulations, Tom. We'll be reaching out to you to deliver your Lego Death Star. Very cool. I'm jealous. And the main question, or the biggest question I wanted to ask you, Kyle, is for more information, what should people do? How do they learn more about VMware Cloud Foundation?
Yeah, so probably the best place right now is we do have a Cloud Foundation blog on the VMware blog site. So go out. I posted a blog on Tuesday with an announcement. It has some links that will point you to our product website, and we will be following up with some additional blogs. But the blogs, we also do have a presence in the VMware community, and so go out to the VMTN community, the VMware community page under the Cloud Foundation. Join that community. You'll get some information there as well. And then, as always, you can always reach out to me on Twitter or directly. I'm happy to provide information. And then, of course, you can always reach out to your account teams or your partners and get more information as well.
Okay. And if people are interested in buying VMware Cloud Foundation or doing a proof of concept, how do they typically do that? Do they go through their local VAR, or how does that work?
Yeah, so because Cloud Foundation is unique in the sense that it's kind of a full SDDC stack, and it has prescriptive hardware, qualified hardware on which we need to run. It's not the type of solution that you can just go and run in a nested environment using Fusion or a workstation on your laptop. It has that dependency. So if you reach out, we do have the ability to, through our hands-on lab and our OneCloud, our public cloud, our internal cloud, provide opportunities. We do social labs. So if you've heard about social labs, we do travel around the world, and we do host in VMware learning locations, hands-on environments where you can do what we're doing for vSTAN, for NSX, and for Cloud Foundation. So if you could find a Cloud Foundation, if you can work with your partner or your VMware account team to get access to a nested environment for a proof of concept or a demo. There's a few options out there. We do have a couple of labs available in the hands-on lab. The 184401 and 184402 that will give you an overview of what it looks like and some of its capabilities as well.
Cool. Yeah, I love the hands-on labs. A great resource, totally free. You can bring up anything, any VMware product, just about in the hands-on labs within a few minutes. And Cloud Foundation is a great product to learn about. So I think that's all the time we have today scheduled for the event. But thank you so much for your presentation, Kyle.
Oh, thank you.
And thank you, everyone out there in the audience, for taking time out of your schedule to join us today. Congratulations to our winner, and I hope everyone out there will join us on future events about VMware and other innovative technology products. You can learn more at events.actualtechmedia.com. Thanks a lot, everyone, and have a great day.
Thank you.